Tucker, get your worksheet out. It says worksheet 3-3A.
That's right. Okay. Are you guys okay if I shut the light off?
Please do. Lucky, lucky, because I'm lucky.
Okay, I asked you to do numbers 5 and 7 only. And I was very clear that I wanted you to do A through whatever. So let's run through these. Is this thing going to be up or down? Up, so that's easy peasy. For B, you have to find the vertex. How do you find the vertex again?
Negative B over 2A.
Yes, negative B over 2A. So that's going to get me negative 16 over 4, which is negative 4. Now that's not the vertex though. That's half of the vertex. That gives you the x coordinate of the vertex, right? So I know my vertex will be at negative 4 comma something, but now I need to find that something. How do you do that? Where do I find this number from? Yes, I'm going to take negative 4 and I plug it into my equation, right? So I can have the calculator do all the work for me, but that's all I'm doing. 2 times negative 4 squared plus 16 times negative 4 plus 29. So I'll just grab my calculator real quick. It tell me what that is. I got negative 3. Did you? So here is another pro tip. Anytime you have these worksheets that are like these computer generated ones, if it gives you a grid, the vertex is gonna, like this grid is gonna match the graph. So if you found a vertex and it was like positive 3, negative 4, it's not part of this grid. So you're already like, oh, that's probably not right. Okay, so the computer has like made it. I wish that there was a way that I could just undo that, but I can't. So, but it fits perfectly. There it is, negative 4, negative 3. It's on my grid. Everything looks great. Part C, you had to give me the axis of symmetry, which is just what? What do you write here for the axis of symmetry? X equals, and then whatever this number is, in this case, it's a negative 4. That's just the equation of this line. That vertical line that goes through, sorry, I can never get the lighting right. I tried this Post-it note over this light and it seemed to have helped, but now. Oh, there we go, that's better. So where was I? Axis of symmetry, there's the equation of the line, perfect. D, now this may or may not show up on your graph, depending on where it is. We're looking for the y-intercept. So to find the y-intercept, what do? You plug in 0 for x. So it's very easy to find. If I plug in 0 for x, don't I just get out a 29? Right? In standard form, that's always just going to be my y-intercept. So 0, 29, which is off my grid. But when I graph my parabola, you can see that 0, 29 makes sense. It wouldn't make sense to get some, you know, some negative number because that is my vertex and I know it's going up like a cup. So I know it's going to cross the y-axis somewhere up in this positive area. It's just off my grid. That's fine. E, you're supposed to solve this thing. You're finding the x-intercepts. So to find x-intercepts, you plug in 0 for y. So I have this now. And now you solve this just like it was on the quiz this week, right? So you can solve by square rooting, factoring, quad formula, completing the square. So it depends. I can't do square rooting because I have an x term. I can try and factor it. So I can see if there are factors of 2 times 29 would be 58. Are there factors of 58 that have to be 16? I don't think there are. So we're out of luck on that one as far as factoring goes. So now it's up to you if you want to do completing the square or quad formula. I would do quad formula. Why? Because A is not 1, so I'd have to divide everybody by 2. And 29 doesn't divide by 2 nicely. So then I'd have to be dealing with fractions. It wouldn't be that bad, but I just don't want to. So I'm going to do quad formula. So let's see. X equals negative B plus or minus big O square root B squared. 16 squared is, I always forget that one. 256. Minus 4 times A times C is 29. All over 2A would be over 4. And then I just have my calculator do all that work for me. So let's see. 256 minus 4 times 2 times 29. If you're using a scientific or graphing calculator, it will do order of operations for you. So I get a 24 when I evaluate all that. The whole thing's over 4. Give me a perfect square that goes into 24. 4. So that's going to split up into square root of 4 and square root of 6. So I get 2 root 6 right there, don't I? So that's just negative 16 plus minus 2 root 6 all over 4. Can you reduce that answer? Yes, because all 3 of these have a common factor. So I can reduce them all by 2. So my X-intercepts would be at those 2 numbers. If I cared to turn that into a decimal, I could actually graph it on my graph. If I don't, I don't know where that is on the coordinate plane, right? So you'd have to go into decimal if you wanted to use that. But lucky for us, I really don't need it because I know that cool pattern that we talked about yesterday. So remember how this works. Let me get this lined up. Normally the pattern is 1, 3, 5. We are just going to take those values and multiply it by whatever A is. So I'm just going to multiply them all by 2. So I get 2, 6, 10. What does that mean? That means from your vertex, to get to the next dot, you just go up 2 over 1. From that point, you go up 6 more. 1, 2, 3, 4, 5, 6 over 1 more. And don't forget, I mean, I would go up 10 over 1, but I can't. It's off my grid. Don't forget, you get to mirror it over for the best buy one, get one free sale that never ends. That's the beauty of it. There's no end to the quadratic buy one, get one free sale. It's forever. So nice. Oh, speaking of which, a coupon at Staples that expires tomorrow. I better get that. It's $10 off 20. Who's not taking advantage of that? And I have ink rewards. Did you say everybody?
No, I said,
Oh.
I was gonna say everything at Staples is overpriced.
I
It doesn't
agree.
work.
You think I pay out of pocket? No,
Exactly.
I use my ink rewards.
That's
I
what
get $40 a month for free to spend there. I know. And even if I don't have anything to buy, I can buy paper towels. They have laundry detergent. I can buy anything. I looked for Easter candy because I'm like, oh, I have all this money, so I gotta buy Easter candy. They didn't have anything that particular about my Easter candy.
Cadbury eggs.
Yes, the mini ones.
Mhm.
That's what I like, the mini ones. Yeah.
It's the only way to go.
I enjoy the cream ones too. I have very fond memories. You know the little Russell Stover ones that come in the foil wrapper? That's like the marshmallow covered in, oh, my grandmother used to do so many of them. She went nuts for Easter. I still have my Easter basket from when I was little. But she was so cute. So it was a basket, it was a normal Easter basket. And then somewhere she found like confetti with all of our names on it. So like it's like plastic cut out that says Erica. So she took this confetti and she put it on everything for it. So it's on my Easter baskets. Whenever she sent us a birthday card, she'd like tape it on. Oh, she's so cute. And tomorrow's her birthday. Oh my God. Oh no. Oh my God. Oh my God. Hold on. Right? I'm not messing this up. I want to make sure that I'm right. Tomorrow's her 100th birthday.
Wait, that's good for her.
I mean, she passed, but oh my God. Do you want to see her? She's I have a picture. She's the one that I wrote the book about. Oh my gosh. How cute. She's holding a graphic calculator. Oh my gosh. I bet she would have loved quadratics. I can't believe, how did I miss this? I didn't yet.
At least
but
you caught it.
I
before.
did, yeah, I knew it was her birthday, but I just didn't put the pieces together. I was 100, holy crap. Oh my God. Anyway, what am I even talking about? Staples, the coupon. Anyway, where am I? Number 7. So 7's kind of weird because your vertex doesn't happen at a lattice point, but that's okay. So what? Do vertices have to happen at a lattice point? No, obviously not, because this one doesn't. Let's see where it is. Is this going to be up or down? Down. Vertex, negative b over 2a, right? Positive 7 over a negative 2. I am going to turn this into decimal because since I'm graphing, like a fraction doesn't really mean much to me. Oops, sorry, I didn't realize I was off. So my vertex is at negative 3.5 comma something. Have the calculator do the work for you. You don't have to do it. So negative. Oh, by the way, you got to be real careful when you're plugging that in. I just want to point this out. Here's what I'm plugging it into. Negative x squared minus 7x minus 10, right? When you want to plug this into there, please watch how you're supposed to do it. That negative is still there. I'm replacing this x with negative 3.5. When you are plugging in a negative number, especially when you're squaring it, you have to put it in parentheses. Now I have minus negative 7 times a negative 3.5 and then a minus 10, right? So please watch how to evaluate this. You have to do this squaring first, and then you take the opposite. So this chunk right here, I know so many of you are like, oh, minus a negative, it becomes positive. You got to do the exponents first. So we're going to do negative 3.5 squared first. Yeah. Take the opposite. So that's actually a negative 12.25. And then that'll be a plus 7 times 3.5 is 24.5 minus 10. And then my calculator does all that stuff for me. $2.25. Did you get 2.25? Those of you that did it? Oh, that's better. Okay, good. All right, so this thing is going to be at negative 3.5 comma 2.25, which I know feels weird, but that's okay. Let's see, negative 3.5 and then 2.25 would be right there. Is everybody with me so far? Is that a yes? All right. Now, A is a little weird. I mean, it's just a negative 1. So instead of 135, we're going to multiply all those by a negative 1. So I get negative 1, negative 3, negative 5. All right, cool. Now, it is strange because I'm not starting at a lattice point, but that's okay. I'm just going to go down one whole box. So I just won't ever be at a lattice point. So what? So from here, I'm going to go down one whole box, which would put me here. And I got to go to the right one whole box. So I'm right there. Oh, I forgot my axis of symmetry. From that point, now I'm going to go down 3 boxes. So 1, 2, 3 over 1. So I'm landing right there. Don't forget to mirror these things over. That one's there. And then this one right there. connect with a nice smooth curve. Ta-da! And it's everything we thought it would be. It's upside down. It's got its vertex in the right spot. Oh, you know what we didn't find? Oh yeah, we're up to C. The axis of symmetry is just x equals -3.5. Y-intercept. I'm expecting it to be some negative number right down here. So if I plug in a 0, what comes out? If you plug in 0 for x, what comes out for y? -10, which totally makes sense, right? I can see it on my graph. If I could zoom out, it would hit there. E, so let's replace y with a 0. This one actually ends up being really nice because you can just factor this thing. Oh, sorry. So we're here. Let's divide everything by a -1. Make our life even easier. What are factors of 10 that have to be 7? 2 and 5. Which means my zeros are actually at -2 and -5. So let's go to my graph, make sure that I'm crossing at -2 and -5. Yep, ding, ding, ding. And that one, I drew my parabola a little wide, but not bad. Everything is coming up roses. And there we have it. Any questions on this part? No, you sure? The one thing that we did not get to yesterday was graphing the inequalities. So if we look at number 9 real quick, you graph it the exact same way. This is just like when we did the absolute value. The only difference is dotted or solid, and I have to shade. So if I'm going to graph number 9, it's got to be down, right? And what's my vertex? Let's everybody find the vertex of number 9. Is it weird that I have a picture of her tombstone and I just wanted to confirm the date and I'm right. Yep, 100 years tomorrow. Okay, got an answer? Where's your vertex? That sounds right to me. Did everybody get 2, 1? Negative b over 2a will get me -4 over -2, so it's a +2. Plug it back in. Oh, yes, actually. I wonder if anybody got, I think it's 9. Did anybody get 9 as the y coordinate? If you got 9, you did not evaluate correctly. Let me show you why. So it's -x² + 4x - 3. This is one of the most common mistakes. So let's make sure that we get this squared away right now, and we never make this mistake again if we're going to. When you plug in a 2, right? So it looks like this. 4 times 2 is obviously 8 - 3. This chunk right here that I just put this box around, what does that equal? What is this? It's -4. What? But I thought -2 squared was +4. Right, -2 squared is, but that's not what this says. If I want to square the number -2, it has to be in parentheses. If it's not in parentheses, this means square the 2 and then take the opposite. Super annoying. I'm with you because it's so easy to make this mistake, right? 2 squared is 4 and then take the opposite. That's actually -4 plus 8 - 3. And that's how we end up with 1, right? Because you get 4 - 3, so you get a +1. Okay, be careful. Such an easy mistake right there. So 2, 1, and then let's just follow our pattern. It's negative, so I'm going to go down 1, down 3, 1, 2, 3 over 1. And if I could, I'd go down 5, and then I'm just going to mirror these things over. Bloop and bloop. So now, so far, everything has been the same as what I did before. But now, because it's an inequality, I got to ask myself, hey, should this be solid or dotted? And what do you say? Solid, right? And we are looking right here for that information. If it has the bar underneath, then it would be solid. And then I just have to shade. So if y is less than, yes. Oh, for Pete's sake. Knowledge. Can't live with it, can't live without it. Anyway, where would I shade? If y is less than. All right, let's see if that's working. Oh, good. Okay, if y is less than, where am I shading? Yes, down below this curve. So in this case, it's all down here. And that's it. So if you have an inequality, that's the only change that you need to make. Just dot or solid in this shading. So how do we feel about this? Okay-ish? Yeah, I think you're gonna love graphing in vertex form because it's like half the work. You don't even have to find the vertex. It gives it to you. So no more negative b over 2a if it's in vertex form. Wow. I know, so cool. So I have a sheet to give you.
Having fun yet, Rick? You having fun yet?
Yes, I was just gonna say, it never stops, right?
Your butt soft. I like your pants will save you.
Thank you. Little Chris.
Jackson Gardner.
I forgot today was soccer mom, barbecue dad. I forgot. That was well. I'm not a soccer mom yet, but we're starting T-ball soon. So how do you be a T-ball mom? I don't know.
No matter where you go, you need. Did the soccer moms never give you orange slices?
No.
Well, it's literally any school. And if you're one of those moms, you bring orange slices.
I will probably not be that mom.
It's a lot of, it's like a full-time job.
Yeah. Too much. Okay, everybody ready? So you already know how to do this stuff because it's the same as when we did it with what do you call it? Absolute value. So we already talked about the H and K business. It's the same thing. So here's our general formula. A times X minus H squared plus K. So our vertex is just going to be a H comma K, just like it was with absolute values. So vertex is just a HK. Axis of symmetry is the same thing. It's just X equals whatever H is going to be. The y-intercept and x-intercepts, you find them the same way. You plug in 0 for X, 0 for Y. So it's actually super easy. So let's try number 1 together and you'll see how quick this goes. So number 1, is this thing going to be up or down? up, right? Because I'm looking at A for that answer, and A is always the coefficient, the number out in front here. If there isn't one, it's just a +1. So this thing is going to be up. The vertex, it's always the opposite of this number, comma, this number. So you don't have to do any math because that's H, right? The opposite of that, and that's K, whatever that is. So my vertex is literally at just 4, 2. Special.
Can we just FOIL X minus 4? Just do it.
You can, but it's way more work. But it wouldn't be wrong. It's just going to take you twice as long because I already have the vertex now. I didn't even have to do anything. So 4, 2. And now you know how to graph it. You can use the pattern. The pattern still holds for all quadratics. And A is 1 here, so we can just do 1, 3, 5. So from that point, I can go up 1 over 1. So there's my first one. And then I go up 3, 1, 2, 3 over 1. And there is my graph already. So nice. Now to find the other things I need to find, easy peasy. Axis of symmetry is just X equals what? 4 in this case. The y-intercept, oh, what am I writing? 1, 2, 3. It should be A, B, C. Sorry, D. Y-intercept, I still just plug in 0 for X. If you plug in 0 for X, you'd get -4 squared, so +16 plus 2, I'd get 18. So that one's a little bit tougher, but I mean, it's not that hard to plug in 0, right? So if I plug in 0 for X, I'm getting out an 18. And look at my graph. Doesn't it seem like that would make sense? If I could zoom out a bit, it looks like it would cross at about 0, 18. So far so good. And finding the X-intercepts is actually even easier because it's always going to be set up to do solving by square rooting. Check this out. So for the X-intercepts, you just replace Y with a 0. So I have this, X minus 4 squared plus 2. I can solve this by square rooting. I can get the thing being squared, this binomial by itself, and then square root both sides. Look how easy. -2, -2. All right. Can I just take the square root of both sides right now? Sure I can. Why not? What's stopping me? Nothing. How do I simplify the square root of -2? Yes. Don't forget positive and negative. Anytime you take a square root. So we have positive and negative I√2 equals X minus 4. And then all I have to do is literally just add the 4 over and I'm done. Oh my gosh, this is so easy. I know, I'm telling you. I love vertex form. I already knew that I was going to get an imaginary number in my answer. How did I know that? Because I already had my graph, right? I can already tell it's never touching the x-axis. So I knew the only way that that happens is when my x-intercepts are imaginary. Wasn't that fast? I know, I'm with you. So cool. Let's jump to number 6. Yeah, we'll jump to 6. So this one's another one, relatively easy. So let's try, oh wait, not 6. I didn't want to do 6. Sorry, just kidding. Yeah, I do. Yeah, all right, never mind, never mind. I thought I was gonna find one that was 6 is fine. Okay, is it up or down? Up. B, what's the vertex? You can just look at it and tell me. That's it. It's -3, 3. You see that? Always the opposite of that number, comma that number. That's it. Oh my gosh. So then the axis of symmetry is just x equals -3. What's your y-intercept? That one takes a little bit of time, right? Not a ton though. So 0 plus 3 is 3. 3 squared is 9. Times 2 is 18. 18 and 3, 21. Are you with me? Yeah? No? Sort of? Maybe? Okay, cool. And then if I'm going to solve it, it's easy peasy. I just gotta, this one's a little annoying, but you know what? We're Tantasquins. And what? Yes, you are. And do you know what you're called if you're from Massachusetts?
Annoying.
That's funny. I'm not from here, so I find that very funny.
Where are you from?
What do you think?
Did you keep New York?
Yes. Oh gosh. Jeez.
Hey, I'm walking.
What was I talking about?
I had to.
Oh, yeah.
I had
You're
to.
called Bay Staters. Did you know?
Forget
Oh,
about
there's, I thought you were gonna say the other one.
Oh, yeah,
And I
yeah.
was like, oh, that's stupid.
Yeah, no, it's a Bay Stater. Huh. Instead of like a Massachusetts.
Oh, because like the base.
I guess, yeah.
Well, like
Anyway. All right, so where are we? Oh yeah, we're gonna solve this one. You gotta plug in a 0 here.
Forget
Oops. Okay, so this one we're going to solve, and you solve it by square rooting. So minus that 3 over.
What are they going on? It's every year.
Divide by 2. This one is a little annoying because we have a fraction. We gotta take a square root, but you know what? It's not that bad. So I'm here. And I'm gonna square root both sides, right? Did you already square root yours?
Yep.
Okay. Oh, hold on, I'll catch up. The other thing that's annoying about this one is because, so yes, I have the negative, so let's pull out the I. But downstairs, you can't leave it as a square root of 2, right? You're not allowed to leave a square root in the denominator, so how do we fix that? Yes, multiply top and bottom by root 2. And that gets me positive negative I root 6 all over 2 equals x plus 3. And then I'm almost done. All I gotta do is minus that 3 to the other side. And then I'm home free. Negative 3 plus minus I root 6 all over 2 equals x. Yes. So what does that tell me? This thing is never touching the x-axis. So when I make this graph, I would expect that that never happens. And yeah, if my vertex is at negative 3, 3, negative 3, 1, 2, 3. And this is up like a cup. Yep, I'm never gonna hit there. Follow your pattern. If A is 2, where am I going from my first dot? Up 2, and then I go up 6. 1, 2, 3, 4, 5, 6 over 1. Mirror these two things over, and that gets me my full parabola. So nice, so perfect, everything I ever expected. There you have it. I do just want to show you very quickly that you can use the pattern even when A is not a nice number. So if you rewind back to number 2, is everybody okay with 6, by the way? Is everybody all right with everything so far? Yeah, all right. So if you look at number 2, this one has an A value of negative 1/2. So I know it's going to be upside down. Where is my vertex this time? Negative 2, negative 3, right? Is everybody with me? Negative 2, negative 3. So again, normally, watch how this works. The normal pattern is 1, 3, 5, right? It's the odds. I need to multiply all of these by a negative 1/2. I'm going to do it as 0.5 just to make my life easier. So 1 times negative 0.5 is negative 0.5. 3 times negative 0.5, isn't that negative 1.5? And 5 would be negative 2.5. So please watch how this works. You ready? So instead of going down, normally I'd go down 1 whole 1 over 1 whole 1 if A were negative 1, let's say, right? But in this case, I'm going negative 1/2. So what does that mean? That means you go down half a box over 1. I'm always going over 1 whole unit, but I'm only going down half a box over 1 whole. Then to get to my next one, I'm going down 1.5 boxes. So I go down, there's a half and there's a whole. There's a box and a half, move over 1. You see that? And then the next one, from here, I'd go down 2.5 if I could. Mirror that over to the other side. If you don't love the pattern and you're like, I don't understand what you're doing, I'm gonna mess this up, you don't have to use the pattern. You can always plug in numbers. You can plug in -1 into this and it's gonna spit out for you a -3.5. You don't have, pattern is just a nice shortcut. But if you don't like it, don't use it. I'm not gonna force you to. I'm never gonna know if you have a correct graph. I'm never gonna know if you use the shortcut or not. Any questions so far? Is graphing in vertex form easy? I knew you'd say that. The only thing we have left to talk about is writing the equation if I give you the vertex and another point. So flip your paper over for me. We're going to take a look at number 9. You ready? So check this out. This is actually super easy to do also. So number 9 asked me to write the equation of the quadratic with a vertex here and another point here. Now, so hold on. If I asked all of you, if I said, hey, draw me a parabola that has a vertex at 1, 1, would everybody draw the exact same parabola? No. Some people might draw a really narrow parabola. Some people might draw a wide one. Some people might draw one upside down. There's literally an infinite number of parabolas that have their vertex at 1, 1, for example. But this is what's wild. There is one and only one quadratic in the whole universe that has its vertex at 1, 3 that also goes through this particular point, 0, -1. There's one and only one. So if I said to all of you, hey, draw me a parabola that has its vertex at 1, 3, but it also has to pass through this point. Every single one of you are drawing the same exact parabola. It's crazy, which means I can write the equation of it. How? Let me show you. So remember our general formula. Y equals A times, X minus H squared plus K. Right? Remember this? Check this out. You ready? The vertex is H comma K, isn't it? Huh. So that right there is H. That right there is K. Now, what's this other point? The other point, we're just going to plug in for X and Y. The one thing that we don't know is what A is. We can find it. So all we're going to do is we're literally going to plug into that formula H, K, X, and Y. So step 1, plug in H, K, X, and Y into our generic formula. Okay, so I'm going to plug all 4 of them into the formula. So let's see what that looks like. Y is -1. A is the thing I don't know. X is 0 in this case, minus H is 1 squared plus K is 3. See that? See how we have all the other numbers, and can't I now solve for A? You bet you can. Follow your order of operations. 0 minus 1 is -1. What's -1 in parentheses squared?
1.
+1, right? All right, cool. So that's just A, right? So then I can just minus 3 from both sides. Don't I just get -4 for A? Is everybody okay where that came from? Does that make sense? Once you have A, you pretty much, you have your answer now. All you have to do is now go back to just your generic formula. And all you do is plug in H, K, and A. H, K, A, and you're done. So if I take that formula, X and Y are going to stay in it. So let's see, minus H was 1, K was 3. Ta-da! I like to check myself. I like to say, okay, pretend I don't have any of this information and I just have the equation that I just wrote. I ask myself, what's the vertex of this thing? Just by looking at it. Wouldn't it be at positive 1, 3? Right? Isn't it always the opposite of that, comma that? So that's positive 1, 3. Why, look at that. In the problem, yeah, it said the vertex is at 1, 3. And then if I want to super check myself, I can plug in this case, 0 and see if it comes out with a -1. And it does. Does that make sense? Now, if we take a look at number 11, 11 is actually even easier because they give us a picture. They want us to do the same thing, but you know what A is just by looking at the picture. What must A, look at 11. You already know what A is. Someone tell me. What must, 3. How do you know? Yeah, to get from your first dot to your next dot, you went up 3 over 1. That means A must have been 3, right? That's how I make that happen. If I only went up 1 over 1, then A is positive 1. If I went up 2 over 1, then A would have been 2. But I went up 3 over 1, that means A is 3. So I could go through all the solving like I did in the last problem, but you don't even have to. I already know what A is. And I know what H and K are, don't I? Right? Because can't I just look at this and I know where the vertex is? Where's your vertex? -2, -4, right? You can see it. There it is. And then A is just 3. So if I just put those pieces in, Y equals A is 3 times X minus H. Be careful. So that's H and that's K. Minus -2. Isn't that going to turn to a plus? And then K is a -4. What? Is that easy? Yes. Oh my gosh. Double check yourself. Pretend you don't see the picture. And say, if I just had this equation, it would have a vertex at -2, -4. It does. And the A value would be 3. It is. Isn't that nice? What a nice way to wrap up the week. Shall I tell you what your homework is so you can get it done and have nothing over the weekend? I thought so. I think we're going to do just the evens on the back. So just 8, 10, 12. That's it. 8, 10, 12. You'll notice 8 is a inequality, right? So graphically normal, but then do dotted solid and then shade this. Okay? 8, 10, 12 on the back. Yes. Go so fast. Would you turn on the light? Just one of them. The other one. Oh, no, that one's fine.
And I need water.
So one set of lights used to like buzz. So for like a decade. So I never turned it on, right? I would only use the other ones. But now I'm just in the habit, but it doesn't buzz anymore. But now you know.
Yes.